In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly to thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. All right, take out your chapter 4 practice test. Grab a red writing utensil. I'm about to read off some answers. I think it's short enough. I think I'll just read off the answers. And I think that there aren't many graphs. It should be fast. Let's see what we got. Okay, here we go. Number one. Number one is a fraction. The numerator is 3x plus 2. The bottom is 2. Do we have the right? No. Oops. Hold on. I got the wrong. Let me double check. Hold on. What do you have for f of x? Ah, that's the other version. Oopsies. And hold on. Very funny. Darn it. Don't write that down. Hold on, no. And x squared plus 5x plus 2, is that it? Yeah. Okay. All right, let's try this again. Number one, there is no fraction this time. It is 4x squared plus 14x plus 8. Does that work better? Yeah. Okay, good. Nice one reading the right. Number two is one fraction. The top is 2x plus 5. The bottom is 5. Make sure you get a common denominator. Number three is a fraction. The top is x squared plus 5x plus 2, and the bottom is 5. Yeah, x squared plus 5x plus 2 all on top, and the bottom is 5. Number four, 2x squared plus 10x plus 5. It repeats after number 4? Yeah. Number three, it's a fraction. The top is x squared plus 5x plus 2, and the bottom is 5. Number four is 2x squared plus 10x plus 5. Any of the repeats? Okay. Number two, it's the fraction. Top is 2x plus 5, bottom is 5. Number five, what changes go from parent graph of f to the child graph g? Two things. Up one, half as tall, or something to that effect. Number six, it's upside down. You could also say reflect over the x-axis, and it's moved to the right 3. Yeah.
For number 5, did you say half the size horizontally?
Half the size vertically. Yeah, that would work. Any repeats, 5 or 6? All right, number 7. Two changes. First, it's upside down. You could also say reflect over the x-axis, and it's moved to the right 1. Number 8, there are two changes. It's 3 times taller, and it's moved to the left 3. Any repeats? Any alternate versions? Yeah. Yeah. Number 6 was either upside down or reflect over the x-axis. And the other is move to right 3. Yeah. Which one? Flipped vertically? Yeah, I'll accept that.
over to parentheses.
To the third, correct.
Okay, yeah.
Correct. Yeah, look at the mean, the reason we focus on the parent graph is anything inside the parent graph is input, anything outside the parent graph is output. That makes sense. And it repeats 5, 6, 7, or 8. All right, next page. Identify the parent function and then write an equation for basically the child graph. The parent function is y equals absolute value of x. The child graph is y equals, you could also do g of x equals or something like that. 1/2 absolute value of x minus 1, with a minus 1 outside the absolute value. Yeah.
Could you have 2x inside the absolute value?
Yes, that does work in this kind. Yes. So let me just write this down for number 9. Number 9, you could either have, this is the child graph. It's either 1/2 absolute value of x minus 1, or you could have y equals, this is kind of sneaky, 2x minus 1. Because this would make it, actually I take that back. This would have to be 1/2 inside. Wait a minute, let me double check. That would be twice as wide, yeah. You have to do it that. If you have a 2 inside, it actually makes it twice as narrow because it is the opposite of what you expect. So either of those should work. Number 10, the parent graph is y equals x squared, parabola. The child equation is y equals negative x squared plus 2. Number 11, parent graph is y equals absolute value of x. The child graph is y equals, let me just write it, number 11, yeah. Y equals negative absolute value of x minus 1 with the minus 1 inside, because it got moved to the right one. Make sense? Number 12, parent graph is y equals x squared. Child graph is parentheses x plus 2 parentheses squared with a plus 1 afterward. So 2 to the left and 1 up. And it repeats 9, 10, 11, and 12. All right, number 13. Transform and give the resulting function. Reflecting across the x-axis is turning it upside down. So y equals negative x cubed. That's it. Number 14. Reflecting over the... What?
Yeah.
The computer is an idiot. It was supposed to do a little bit more creative than... Did every single bloody one come out? No.
Not the last one.
I'm just gonna
Are you serious? Wow, Merry Christmas on that one. Just so you know, is the real test going to do that? Probably a little more variety. That was just that's like flipping a heads on a coin like 5 times in a row. It's like, you can do it, but it's like 1 out of 32 chance of doing that. That's insane. Anyway, if you go over the x-axis, you have y equals x cubed becomes y equals negative x cubed. But if you were to do it over the y-axis, remember, over the x-axis is opposite y. Over the y-axis is opposite x. Let me just show you, everybody look up here real fast. Why did the negative show up here? There's 2 reasons. You could think, if you're flipping it upside down, that's an output change. That's true, and that's one way to think of it. But if you did the reflection trick, technically y is going to be replaced by negative y. But you have to get y by itself. So divide both sides by -1. And that's actually where you get your negative x cubed. That's where it comes from secretly. Now, how about if you go over the y-axis, it looks like this. Sorry, whoops. So it looks like that. Did we catch what I just did? If I go over the y-axis, I do opposite x. Every time you see an x, replace it with parentheses negative x. This actually does simplify though. Negative x times negative x times negative x is negative x cubed. So interestingly enough, on number 13, reflecting it over the x-axis or y-axis will give you the exact same thing. Man alive. Okay, number 14. These are going to be really boring. Y equals negative x squared. 15, y equals negative radical x. Number 16, y equals negative 1 over x. Lame. Number 17, y equals negative absolute value of x. And glory be to God, at least number 18, they got a different one. Y equals radical negative x. In case you were wondering, isn't that always imaginary? Only if x is positive. If x is negative, it actually would give you real graph. So, A repeats, up to number 18. Yeah, those are the gimme portion of the test. Number 19, the inverse of this is g inverse of x equals 2 parentheses x minus 2 quantity cubed. So 2 and then x minus 2 in parentheses cubed. Did we get that? Number 19? Yeah, let me just write it down. It was 2 parentheses x minus 2 cubed. So g inverse. That's for number 19. Number 20, I'll just write that out. F inverse of x is this. It's 4 over x plus 1 with a minus 3 afterward. Everybody go with this? Yeah.
For number 19, I got g inverse of x equals parentheses 2x minus 4 parentheses cubed over 4.
Interesting.
How does that?
Oh. I think that's right. Let me work that right now, because I can show it to you. There are a couple of alternate versions which are correct. In other words, that one, if you actually expanded it out, if you cubed it and then divided it by 4, you get the exact same thing I had, I think. Let me double check. So g of x equals, I'm just going to do number 19 together. It'll be quicker. 4 plus the cube root of 4x all over 2. I'm going to make this y. To take the inverse, you switch the x and the y. So x equals 4 plus the cube root of 4y over 2. And now try and get y by itself. First thing you do is multiply both sides by 2. 2x equals, these cancel, 4 plus the cube root of 4y. Then subtract 4. So yeah, I think, Becca, this is going to match yours. Equals the cube root of 4y. Then you cube both sides. Cancel, cancel. So let me just put it up here so I don't have to stoop. So 2x minus 4 parentheses cubed equals 4y. Then divide by 4. Yeah, yours is fine. No problem. Yeah, I have fun grading these actual tests because I have to have like 8 different variations on the answer, and all of them are right. So, yeah. Has everybody got number 19, 20? Number 21. G inverse is equal to, it's a fraction. The top is negative 5x plus 20. The bottom is 7. There is an alternate. If anybody has 5x minus 20 all over negative 7, that's fine. Maybe have any other variations you want to check? Yeah. Yeah. The first version is negative 5x plus 20, and then the bottom is 7. This is 21. And then the other version is 5x minus 20 over negative 7. That's probably more common. Yeah.
Can you just have a negative like before the fraction?
If you had negative in front of the fraction, then you'd have 5x minus 20 on top and a 7 on the bottom. Yeah, that's fine. Any other variations? Number 22. F inverse is equal to the cube root of x plus 1 with a minus 1 afterward. 23. The inverse is G inverse is equal to 1 over x with a plus 3 afterward. 24. G inverse is equal to a big cube root of a fraction. The inside fraction is n plus 2 on top and a 2 on the bottom. There are a few other variations on that, so anybody have anything else? The fact that if yours is different from what I read doesn't necessarily mean you're wrong. Yeah. 23? Yeah, 1 over x and then plus 3. 24 again is the cube root of the fraction n plus 2 on top and 2 on the bottom. Yeah. Hang on. Yeah. 22 is the cube root of x plus 1 with a minus 1 afterward. And it repeats up to 24. All right, number 25. Find the inverse of the function and then graph it. They were annoying and did n. Yet they were kind of being funny and they shot themselves in the foot. If they used n, they should have had the n-axis going left to right, but they used the x-axis. So just pretend that's f of x is equal to negative 6x minus 2. The inverse is f inverse equals negative 1/6 n plus negative 1/3. Did anybody have negative n minus 2 over 6? That's fine. That's also fine. It's not as easy to graph, but that works. Let me just write these down. 25. I will try and make sure that they use x instead of n in there. Just pretend that's x. So f of n is equal to negative 6n minus 2. We're going to pretend this is y. I find this aggravating to switch n, but all right. N equals negative 6y minus 2. Get y by itself. So n plus 2 equals negative 6y. And if you had n plus 2 over negative 6, I'm okay with that. Does that make sense so far? Now, to graph this, you'd have to split it up. This is y equals, there's a 1 here. So it's negative 1 over 6n plus negative 2 over 6, which is negative 30. Does that make sense? Now, graph the original function and its inverse. Interestingly enough, if you can graph this, just pretend this is x. The y-intercept is 2. Negative 2, right? And then the slope is negative 6 over 1. If you have a graph that's small, here's how, there's two ways to do this. You can either drop 6 and over 1, which actually goes off screen, or you can go backward. 1, 2, 3, 4, 5, 6. Up 6 and left 1. Either one is going to give you the correct line. So this is the graph of that. Does anyone remember the sneaky way to graph the inverse? You don't even need to try and graph this formula. How do you graph any inverse graph? Yeah. Flip all the x's and y's. This one is negative 1 comma 4. It should go to 4 comma negative 1. I'll just do open dots here just for an instant. Oh, actually, I'll do solid squares. This is 0 comma negative 2. That should go to negative 2 comma 0. And then this is 1 comma negative 8. It should go to negative 8 comma 1. And there's your line. So here's what F inverse should look like. Does that make sense? Yeah.
So you say in the directions that you have to have at least 4 guide points?
Oh, 4 guide points. Oh,
But
you're
with
good.
this, there's
That's a
only
very
2.
good point. This one, it wouldn't have made a lot of sense. 3 is fine. Actually, even 2 is fine if it's a line.
Let's do one.
That was, I know why that's there, that was my fault. It was left over from a parabola. The reason, there might possibly be a parabolic graph there, but probably not. So I'll change that on the actual test. So, any repeats so far? 25? Extra credit, number 26. I need it all over in one fraction. It is as follows. The top is 4x squared plus 54x plus 76 all over 25. Let me say it again. Bless you. Number 26. It's all one big fraction. The top is 4x squared plus 54x plus 76 all over 25. I'll show you that a little later. Number 27, state if the given functions are inverses and prove your answer. Yes, those are inverses. You could use any of the four methods. I plugged one into the other and the other into the one, and they both came up with n, which means they cancel. And number 28, how do you graph a cube root? We haven't practiced graphing cubes. I gave you the parent graph for cube root, or cubes rather. If anybody remembered it, bravo. Otherwise, use a table. Here's what it looks like. It's f of x equals, parentheses x minus 2 cubed plus 2. Look over here. Y equals x cubed is one of the parent graphs. So the pattern for this thing is it's centered at 0, 0. Down, please. Over 1 plus or minus 1, up plus or minus 1. Over plus or minus 2, up plus or minus 8. Over plus or minus 3, up plus or minus 27. You're cubing the x in order to get the y. So you start at 0, 0, right 1, up 1, left 1, down 1. It looks like a line so far. Then you go over 2 and up 8. That's probably as far as you need to go. And then left 2, negative 2. So 1, 2, 3, 4, 5, 6. Down to negative 8. That's the basic graph. It'll flatten out for an instant and then swoop back up. That's the basic graph of a cubic, of a parent graph cubic. The only differences are it moves 2 to the right and 2 up. That's the new graph. Let me try that. The center is normally 0, 0, but I'm going to move 2 to the right and 2 up. There's the center. I'll put a little X for the center. Now do the same pattern. Over 1, up 1. Left 1, down 1. Over 2, up 8. So it's already at 2. 6, 7, 8, 9, 10. So it's going to reach a height of 10. And over here, it's over left 2 and down 8, so it'll be down at negative 6. Here's your graph of the original. Does everybody follow what I just did there? Again, it was a little tricky to remember the parent graph for y equals x cubed. If you get stuck with the parent graph, do a table. Negative 3, negative 2, negative 1, 0, 1, 2, 3. And you'll find out this is negative 27, negative 8, negative 1, 0, 1, 8, 27. And the graph will pop up. Again, if you remember your moves resize as flips for number 28, there's a move 2 to the right and a move 2 up. That's the original f of x. How do you graph the inverse? They did also want the equation for the inverse, but you don't need the equation in order to graph the inverse. How do you do it? Yeah. How do you graph the inverse? How do you graph any inverse? Right, flip the x's and y's. This is 4, 10. It should go to 10, 4. This is, the center is 2, 2, that'll stay put. This is 3, 3, that'll stay put. 1, 1 stays put. And this is 0, negative 6, so it should be negative 6, 0. So it should look, I mean, it's not supposed to be dotted, but here's the, I would have done a different color. There's the inverse graph. Make sense? Now, how do you get the inverse? Switch the x and y for the formula. So you get x equals cube root of y minus, or cube of y minus 2 plus 2. Now get y by itself. Subtract 2. Then that's y minus 2 cubed. How do you get rid of a cube? Yeah.
Cube root.
Cube root. Make sure you do it to both sides and the entire side. Cancel, cancel. So y minus 2 equals the cube root of x minus 2. And then add 2. Make sure that's not in the radical. So y equals the cube root of x minus 2 with the plus 2 on the outside. And that's your formula. So you need two things for number 28. Well, three. The graph of the original, the graph of the inverse, and then the formula for the inverse. Any repeats anywhere? All right, I am open to questions. We have 25 minutes. Hit me, metaphorically speaking. Yes. Any of those you wanted to see dissected? You. Okay, now I will grant you the problems like 13, 14, 15, 16, and 17, I don't expect a heck of a lot of questions. But the other ones, how you doing on those? Yeah, go. Number 4. Yeah, g of f of x. Let's try that one. Do me a favor. Can somebody give me f of x on the front page? Keep going.
It's x squared plus 5x plus 2.
Plus 2. And what's g of x?
It's 2x plus 1.
2x plus 1? Okay. So g of f of x. Here's one way to think about it. The most risky thing is getting the order right. Figuring out what this is talking about. Question. Can somebody calculate g of 10? Just based on this stuff. How would you calculate g of 10? Like, give me the steps. Yeah, plug in into which formula? Yeah, so what would it look like? Does that make sense? And it's 21, I think. What's g of triangle? Becca. You can't do much. Yeah, that's it. Some weird thing I sometimes do to, g of chicken, it's 2 times chicken plus 1. So whatever you plug in, it's 2 times that thingy plus 1. Look what they're plugging in. It's g of f of x. So it's going to be 2 times f of x plus 1. Does that make sense? Now that is your answer. Now just simplify. 2 times what is f of x? Fill it in. And the order of operations says multiply before you add. So distribute the 2. 2x squared plus 10x plus 4, and then plus 1. And in the very end, you get 2 like terms there. 2x squared plus 10x plus 5. Got it. Does that make sense? Next. Yeah. Number 2. Yes. G of h of x. Let me put h of x up there. H of x is x over 5, is that right? Okay. So g of h of x looks like this. What does g do to its inputs? Actually, Nate, help me out. What does g do to its inputs? When you plug something into g, and what happens to it? Yeah, it multiplies by 2 and adds 1. Do that. It's 2 times h of x plus 1. Do it. What's h of x? X over 5. Do it. What's 2 times x over 5? 2x over 5. This is your answer, but I still need it simplified. They need a common denominator. So what kind of denominator? 5. Ta-da. So it's 2x plus 5 over 5. And that's it. Does that make sense? Next. Any others you want to see? Sure. 3. Yeah, 3 was the, well, okay, well, I'll talk about that in a minute. Look at this thing off. H of f of x. So question, let me see. Mary, help me out here. H of x, what does it do to inputs? When you plug something into the function h, what does it do to it? Like if I plug something into g of x, it multiplies it by 2 and then adds 1.
Oh, okay, so it just divides it by 5.
Exactly. It divides by 5. So what if I did this? H of f of x. What am I plugging into h?
You're plugging in x squared plus 5x plus 2.
Right. And then where would I put that?
So you just do that divided by 5.
Got it. Because basically it's f of x over 5. And that's exactly what we did in Newton. There's really nothing more to do. Questions? Next. Any others you want to see? How'd y'all do number 1? Everybody okay? They plugged in g of x, so it's g of x squared plus 5 times g of x plus 2, and then simplify. How y'all doing on number 5, 6, 7, 8? You okay, Emma? You tell me the actual thingies. Hang on a second. Let me show you something. Yeah.
Just for 5, so if you have like the half next to the x like that, that still counts as input?
That's output.
Or,
Yeah. The only time it's input is if it's inside the cube, if it's being cubed. Like if it's inside the parent graph. 1/2 x parentheses cubed would be like this. That would be an input. But if you have 1/2 x cubed, this is output. It's saying, is it being cubed or is it not? Is it inside the main function or not? That'll be input or output. Okay. I want to try one just because I vaguely remember something on the test which might catch people off guard. Try this. I'm going to give you two, the parent graph is x squared. Tell me the equation of this thing. And that's right now, there are two correct answers. One of them is easier to find than the other. Parent graph is x squared, plain old x squared. What do you think?
maybe 2x squared.
G of x is equal to 2x squared. How do you get that?
So instead of going over 1 up 1, it goes over 1 up 2.
Over 1 up 2, and then check the next jump. Over 2 up what? Yeah. What is it normally?
Over 2 up 4.
Over 2 up 4. All the heights are twice as big. Think you could do that? Yeah. Question.
Oh, well, I was gonna say the other one.
What is the other one?
Is it like,
It's very hard to. It's a trickier one.
isn't like parentheses 2x parentheses squared?
Close. 2. I'll show you. It's actually this. Does everybody see how I got that? This is really, like, where the heck did I get that? Square it for me. What's radical 2 times radical 2? 2. And x times x? Yeah. Sneaky. Here's another one. This is a little easier to see. Can anybody give me the equation of this graph? It is based on a parabola. It is a parabola. It's a very, very skinny looking parabola. What do you think?
4x squared.
Y equals 4x squared. Because it's over 1 up 4. There's another version. Anybody see it? Yeah.
Maybe like parentheses 2x squared.
That's 2x parentheses squared. And I'll show you why. Normally, it's over 1 up 1 over 2 up 4. Oh, math people who remember your input-output changes. What happens when you multiply the input by 2? Go.
Half is wide.
Half is wide. Normally, it's over 1 up 1 over 2 up 4. This is over 1/2 up 1 over 1, sorry, over 2. Let's try this again. Over 1 up 4 instead of over 2 up 4. In other words, everything got crunched to half as wide as it used to be. And it does work. It's easier to look at this one. Heights are much easier to deal with than widths. Width, everything goes backwards and you have to compensate for the fact it's going backwards. You can almost always translate an input change to an output change. Not always, but in our cases, almost always. So I would say, if you can find an equation for output, use it. If you want to be totally creative and try and input one, do it at your own risk. That might be a great extra credit question for the exam. They say, give me the input variant of how to make that graph. We'll see. Any other questions? Let me get number 26 out of curiosity. Anybody want to see 26? Okay. 26 is, well, let me do it. F of h of g of x. Let me give you the f, g, and h first of all. It's the same formulas as the other page. So f of x is equal to x squared plus 5x plus 2, I think. And then g of x is equal to 2x plus 1. And h of x is equal to x over 5. They want f of h of g of x. Now that's a little bit of a mess. You got to start somewhere. If you have parentheses, 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 where do you start? The general. Okay. The inside. You start with the inside. They're plugging in g of x, but they're plugging it into what? They're plugging it into h of x. So do you see the little miniature problem, h of g of x inside? Let's see what that is. H of g of x, it's plugging g into this thing. It should be 2x plus 1 over 5. Does that make sense? So if you do the inside thing first, this is 2x plus 1 over 5. So you can simplify it like this. Again, do the inside first, it's easier. Now plug that monstrosity into that. Here's what it looks like. It's going to be 2x plus 5, plus, sorry, 2x plus 1 over 5 squared plus 5 times 2x plus 1 over 5 plus 2. Did we see it visually where we got that? This is basically f of x squared plus 5 times f of x plus 2. That make sense? the thingy. Yeah, well, actually not f, it's the, yeah, this thingy squared plus 5 times this thingy, well, anyway, it's this. This, square the first, double product, square the last. 4x squared plus 4x plus 1 over 25. Square the top and square the bottom. This one, this is 5 over 1, and the 5's cancel. So it's 2x plus 1, Merry Christmas. And then plus 2. I need a common denominator for everything. This is over 1, this is over 1. What common denominator do I need? 25. Multiply this by 25, multiply this by 25, so it's going to be 50x plus 25. And do the exact same thing here. 25, and then this is 50. Add the tops, you're going to have 4x squared plus 54x plus 75 all over 25. 70, did I say something? Oh, 76. I forgot the 1 over here. Ta-da. Does that make sense? Any others you want to see? How'd ever do a number 27, extra credit? You can use any method you like. You can try and get f, find the inverse of f and see if it looks like g, find the inverse of g and see if it looks like f. It's a little tricky when you're taking cube roots because they might simplify on you. My personal advice is try and plug one into the other and the other into the one and make sure they both cancel. That's usually the most and you don't have to worry about simplifying. It's just they should both be identical. Any other questions? Any other variations on any of those you'd like to see? I could probably pull one off the top of my head if you want. Everybody okay on the plugging one function inside another? There will be different functions, of course. Everybody's okay on transforming graphs, moves, resizes, flips? Let me see. Telling what the parent graphs are. Can somebody name the parent graphs for me? Because I might use different ones. I gave you 7 of them. You're responsible for 6. You do not need to be responsible for x cubed, except as extra credit. Can somebody name me the first parent graph? Go. That's y equals what?
Y equals x.
Y equals x is 1. Give me another one. Any parent graph you can think of. Y equals x squared. Give me another one. Y equals radical x. Give me another. Becca. Absolute value of x. Correct. Give.
1 over x.
Y equals 1 over x. It's the reciprocal function. Hey, remember the 6th? Yeah. Y equals negative x is actually a variation on this. It's actually a super duper easy one that we never see. Y equals 0. It's the horizontal line. You can raise or lower it and make y equals 5, y equals negative 3. But that's that. And this, again, the 7th one is y equals x cubed. You're not going to be on for that as a regular problem. Possibly extra credit, but other than that. So if it says name a parent graph, it'll be one of these 6. And then you just see what the equation is and look for the moves, resizes, and flips. Doing okay? That is all I have for you. So you're welcome to take the last 5-6 minutes, let your brains cool down, study, pick my brain for any last questions you have. Otherwise, I think we're set for the test tomorrow. Right. We're still recording, isn't it?
Yeah.
No.
Yeah, feel free to do that. Bye, everybody.